How are you?
I'm good.
How was your weekend?
It was great. You know, May's coming to an end, so I watched more movies.
How many movies do you think you watched this month?
Watched like 10, I want to say. I asked my friend the exact same thing and she watched 6.
That's a lot of movies. Where do you live again?
LA. Well, 10 movies isn't that much if you consider the fact that I've watched these movies throughout the entire month of May.
What? That's right. I actually watched 7 movies. It's not that much now that I think about it.
Wait, where do you live?
I live in Carson. Why?
Wait, I just have a great idea. What if there is an association between the cities that we live in and the amount of movies that we watch per month?
Interesting. How about we collect some data? I think I'll call my friend to see how many movies she watched this month. Hello, Tracy? I'm collecting some statistical data. I was wondering if you could tell me how many movies you watched this month. So you watched 8 movies this month? Put Erica on the line. I want to see how many movies she watched. Hey Erica, how many movies did you watch this month?
You know who we should call? We should call Professor Shirey. He can give us some data too. He can ask Elliot and Lee and that one guy that's always asking questions in the front.
Oh look, he's calling me right now. How about we ask him? Professor Shirey, Edith wants to ask you a question.
Hey Professor Shirey, we were trying to see if there's an association between cities that you live in and the amount of movies that you watch per month. So how many movies did you watch this week? 3? How about Lee? Lee watched 4. How about Elliot? Oh, he watched 1 movie. How about that your other student that always sits in the front? Oh, he's studying for stats, of course. He watched none. Okay, and you live in the city of Irvine? Great. We're gonna put some data for you. Have a great day.
I'm so excited. Now we have data for people who live in the city of Carson, LA, and Irvine. I'm so excited. Let's go do the math.
Wait for me. Well, you ran away super fast from me. I wanted to tell you, I think we should use a one-way ANOVA to solve this problem.
You should have ran faster. I literally just did it right now. Look.
Well, explain it to me while I catch my breath,
We're
please.
testing to see if there's an association between the city one lives in and the number of movies that we see per month. So Isabel, me, I collected data which was 7, 8, and 6. In order to get our mean, we added up, divided by 3, and we get 7. And Edith's data was 10 and 6. We got 8 as our mean. And then Professor Shirey, Elliot, Lee, and the person who sits in the front and asks questions, well, our mean was 2. So now, in order to get the degree of freedom, the way we calculate the degree of freedom for degree of freedom within is n minus k, which is the total number amount of like data that you have minus the categories, and we get 6. And now to get the degrees of freedom for between is k minus 1, which is categories minus 1, and you get 2. So
Can you tell me how you got the degrees of freedom total?
the degrees of freedom total is just by adding 6 plus 2, and we get 8. Main formula n minus 1, which is 8.
So I finally caught my breath and I was listening to your explanation and all of this makes sense. So let's kind of get the numbers down to see if there is an association. Alright, so for Isabel's group, Carson, she lives in Carson, our mean was 7 and those are our numbers. So we're going to have to subtract our mean by every single number in that category. So now we have 7 minus 7, 8 minus 7, 6 minus 7. When we do the math for all of that, then we're going to get 2. For the LA data, that was me, our mean was 8, and we had 2 people. Someone watched the movie 10 times, someone watched the movie 6 times throughout the month, so it's 6.
Just a side note, the numbers we are subtracting are also being squared to remove the negatives.
For Shirey's group, the mean was 2, and these are the numbers. So once we go ahead and do all the math, we have 10. In order to come up with the sums of square within, we need to add the 2, the 8, and the 10. So that gives us a total of 20. So our answer would be 20, and we have that here, but I'll get to that formula in a minute. The sum of square between is going to be the grand total mean. So once we add up all these numbers here, these 9 numbers, and divide them by 9, we're gonna get 5. So that's why we have 5 here. And we subtract the grand mean from each mean of the groups. So for instance, 8 minus 5, that was the LA group. There's only 2 people in that category, so that's why we put the 2 in the front. For the other one where it's the mean was 7, for Carson, we subtract the grand mean from 7, and there's 3 people in that category, so that's why we're putting the 3 in the front. For Shirey's group, There's 4 people in this category, so we're gonna subtract his mean, which was 2, minus 5, which is the grand mean. And once we do all the math, we have that here. Our total is 66. Now, in order to go ahead to get our F statistics, we need the formula MS between, MS within. But we only have sum of squares within and sum of squares between. So how are we gonna get here? Well, that's really simple. All we need to do is divide the sum of squares within by the sum of squares within degrees of freedom. Then
Correction, you divide by degrees of freedom within.
Degrees of freedom between. Isabel already explained that in the beginning. So we're gonna plug in the 66 to the top. We're gonna divide that by 2. Then we're gonna take the 20 from the sum of squares within and divide that by 6, and that gives us 3.33. And then 2 divided by 66 gives us 33. So once the math is done for that, our F statistic is 9.909.
The way we find our critical value is we use our F table, and we have our 2 on the top, which is the degree of freedom for between, and we have 6 on the bottom, which is our degree of freedom for within. And by looking at our table, we end up with the critical value 5.143. And knowing what our F statistic was, we can clearly see that we reject the null in this example. So our conclusion would be that there is at least a small population mean that is different from at least one other mean. There is an association between city one lives in and a number of movie they see per month.
Isabel, you're super smart. Our data checks out. This was so much fun. We just, made up a problem for ANOVA using the information from our friends.
All right, thank you, Professor Shari, for the extra credit.
This is our last stats class with you, so 10C is gonna come to an end pretty soon, but we really enjoyed having you as our professor, Shari. Thank you.
Thank you.